And thanks for coming, and thank you for having me, Mahailani. It's really nice to be here. I don't get to come out this far very often, so it's really nice to be here on a nice day. So I have not prepared a talk that will go the whole hour, and I like to run things fairly informally and have it interactive. So if you have a question while I'm talking, just raise your hand or shout. I don't mind questions while I'm talking, so that is fine. Okay, so I'm going to tell you about a program called Laulima ʻIke Pono, which ran at Heʻeia Fish Pond for 3 years, and it was a partnership between the Hawaii Institute of Marine Biology and Paepaeʻo Heʻeia. It is currently not running, but we're trying to find funding to actually continue it. So I'm going to tell you about the project, and if you all have any ideas for me to fund it, that would be fantastic also. But right up front, I'd like to just tell folks about who I work with. Oh, and Laulima ʻIke Pono essentially translates loosely to working together for the collective vision. And the collective vision is essentially trying to restore Heʻeia Fish Pond while also promoting science and community learning. So the program was funded by the National Science Foundation to the University of Hawaii, and these are my colleagues at UH. Flo Thomas and Kathleen Ruttenberg are also faculty at University of Hawaii. Paepaeʻo Heʻeia, their executive director is Hi'ile Cabello, and she was a very important partner for us here. And then really the folks that did a lot of the work are the graduate students that were working as researchers in the fish pond, and I'll tell you a little bit about that in a few minutes. But at HIMB, we had Cheryl Leonsoon and Megzi Seipel. They really were involved kind of throughout the whole program, but we also had other students in oceanography, Becky Briggs and Danielle Hull. And then another really important person who was a graduate student at the time, and actually is now a graduate student at UH as well, but in political science, is Auntie Donnie Campbell, and she served as our cultural advisor for. That
Donna is on the HCBA.
Oh yes, she just did. Yes, that's right. She told me. Yeah. So she's wonderful. I love working with her. But these folks were pivotal to this whole program happening. Okay, so the goal of the project was to develop a program by which our community members could receive training in scientific research that was culturally relevant. And so not just disconnected research that might not have importance to their daily lives, might not have importance to their interests. And I should mention that the program that funded this at the National Science Foundation was called Opportunities for Enhancing Diversity in the Geosciences. And so one of the goals is to broaden diversity in the geosciences to get underrepresented students and members of the community more involved in science and have career opportunities in those geosciences. So we wanted to create something that essentially blended scientific research and cultural practice and relevance. And a great place to do that is at Hawaiian fish ponds. This is Heʻeia Fish Pond in Kaneohe, Oahu. If you're not familiar with the island, we're over here at Hanauma Bay, and it's located over here. The Hawaii Institute of Marine Biology is located right in this part of the bay here. So it's just a little more than a stone's throw away from us on Moko'oloi or Coconut Island. So the program, as I just alluded to, was really built on two things: strong research foundations and strong cultural foundations or community foundations. And that is because Heʻeia Fish Pond is about 800 years old and has served as a community resource both for food and cultural practice for the community for many years. It is in disrepair right now. It has a hole in its wall, and that's part of the restoration that's going on. But they have a very vibrant community volunteer program and education programs that is turning. This was what the wall looked like sometime around, this is one part of the wall, sometime around 2001 or 2, and this was a few years later. They haven't completely repaired the wall. In fact, I'll go back here. This is the break that I'm talking about. It was created about 50 years ago by a very big storm that went through all of Kaneohe Bay. And they're clearing mangrove from around the wall. So this type of fish pond has a wall all the way around it. And they started here, and they have cleared in the last 10 years that they've been working by hand, they have cleared mangrove to about here. And so they're now working on this area here, which is right near Heʻeia Stream that runs out into the bay right here. So they're clearing the mangrove, they are restoring the wall, and this is the last piece that they received permitting for from our Army Corps of Engineers and Department of Health just in the last 6 months. So they just started a campaign to close that hole in the wall. Okay, so as I said, very strong community foundation here with Paepaeʻo Heʻeia, which is the community organization that is the steward of Heʻeia Fish Pond. It does sit on land that's owned by Kamehameha Schools. So Paepaeʻo Heʻeia is leased the land, but Kamehameha Schools also supports their education efforts and gives them funding to do those things. And then also strong science foundations that were already happening by the time we created this internship program, this opportunity for community members to get involved in science. So biogeochemistry and nutrient cycling was something that was already being studied in the fish pond by some folks in oceanography and at HMB. Those are the people that I mentioned early on. Dr. Flo Thomas and Kathleen Ruttenberg had been doing some work in the fish pond already. And just because it's important, but because we are here at the at the Education Center that's run by Hawaii Sea Grant, a lot of this funding was started out with Hawaii Sea Grant funding. So a lot of the research was started out with Hawaii Sea Grant funding. They provided seed money that got things going, and then there have been other grants that have built on that. So things like sediment coring and benthic mapping were already happening in the fish pond. And then there were some new research projects that were going to get underway. So essentially what you had was mangrove removal happening in the fish pond. And this is some series of dates of mangrove removal for the fish pond here, along with a very intensive scientific research protocol. All of these numbers, I know this is a little blurry, but all of these numbers represent different kinds of sampling sites, either sediment geochemistry or water sampling or biodiversity sampling. So we already had this good foundation to build on. And this is what we really wanted to accomplish in the program. We wanted to provide access to advanced science education and careers for our local students and community. We wanted to promote community awareness and involvement in fish pond research and in the fish pond restoration. So we wanted to help Paepaeʻo Heʻeia actually get their message out to come get involved in the fish pond and help with the restoration. We definitely wanted to help strengthen relationships between sometimes disparate, but really mostly synergistic knowledge systems, and that is traditional ecological knowledge and scientific research. So we were really hoping to build more bridges there. And sharing science with research with the public. Those results we felt was really important. Anything that our community members, our interns were doing, it was important to share that. And so at the end of each of our internship programs, we made sure that we hosted a sharing event at the fish pond. And then of course, over time, by providing scientific information and helping with restoration, we were hoping that we would contribute to improved functioning of the fish pond so that it actually could serve as the community resource it was intended to, and that is to grow fish. Okay, so the internship itself consisted of 3 years of 6 months internship rotation. So we had cohorts of 8 interns work as a team for 6 months with one of our graduate student researchers in the fish pond. And we focused on our community members. We recruited community members from Ko'olapoko region of Oahu, which is where the fish pond is. That was their request. But in fact, we actually got a lot of applications and interest from students at University of Hawaii. And so although we gave preference to community members in that particular region, we had community interns from all over, in fact, even some internationally. And we also didn't just limit it to undergraduate students or any particular age. Anyone over the age of 17 up until whoever wanted to join us was welcome to apply to the program. This is one of our interns who was fantastic. He's also a volunteer out at Kualoa Ranch, but he's retired and came and did an internship with us and lives in the area because he was interested. He did this internship. So we had a big range of interns, and I liked that model because there was a lot of intergenerational learning then, a lot of intergenerational interaction between our interns. It wasn't just one demographic of students or interns. So then the interns worked anywhere between 8 and 12 hours a week, at least 2 days a week they were out at the fish pond. And then we had monthly sessions with our cultural advisors, both Hi'ile Cavello, who is the fish pond executive director, and then Donnie Campbell, who I mentioned also. We had also monthly service days. I'll mention those. They received a stipend. And then if they were interested in learning more about college or wanted help with college applications or information about graduate school, we also provided that on an individual basis. Okay, so scientific research, the students were involved in research that was really would have been very difficult for our graduate students to do without a lot of hands, with a lot of help. And they were involved in all aspects of the research, from building some of the equipment that they work. These are cages being built. These are poles for determining water and sediment heights. So they had to build the equipment as well as use it. So they got involved in all of the aspects. This is essentially what field research is. You have to do a lot of it yourself. And then they got to practice with this is Cheryl, one of our graduate students. They practiced a lot on land before they went out into the fish pond. And I'm going to tell you about a couple of the research projects that they were involved in. This one was to better understand the impact of red mangrove on the fish pond. So I had showed you that picture of mangrove essentially growing on the fish pond wall. Mangrove was introduced to Hawaii in 1902. It made its way to Heʻeia in about 1922 was the first recorded sighting of it, I think. And it's not very good. It's not native to Hawaii, and it's not good for fish ponds because it infiltrates into the walls and the roots break up the dry stack walls. It also provides a windbreak, and that's actually important. Wind is important for the way fish ponds were designed because it stirs up the water. It provides water flow and mixing of sediments. So when you close off that wind, the pond becomes stagnant. And also the other thing that mangroves do is they collect a lot of sediment. That's why they were introduced to Hawaii, is so that they could collect sediment runoff from all of the agricultural practices that were happening on the time and things that were not very good for our resources, our marine resources. We had a lot of sedimentation coming into our bays. So there was an idea to bring in mangroves to help stop that. And they do their job that way, but they actually have probably more harmful impacts for fish ponds and other areas. The other thing that they do is because they increase sedimentation and they decrease water flow, is the fish pond becomes very low in oxygen. It's not getting circulated enough and it becomes very shallow. So one of the studies that our graduate students was doing was to understand Rhizophora mangle is red mangrove. And the impact on the benthic communities. Benthic communities are organisms that live on and in the sediments. And so from previous research, it was known that the litter fall, that is the leaves essentially that fall into the fish ponds or anywhere actually, in Hawaii, because Hawaii is not native, because mangrove is not native to Hawaii, there are really no consumers of those mangrove leaves here in Hawaii. There are in other places, but not here. So it's not consumed by the benthic invertebrates, which means that it builds up. And previous studies also showed that the infaunal communities are somewhat different between an intact mangrove here and mangrove that has been removed. So you'll find differences. And so this is something that's actually been removed. This also shows, this is a really good example of the sedimentation that happens in mangroves. All of this sedimentation was created actually by the mangroves themselves. Infaunal communities are things that live between sediment grains. So in the sediments and very, very small, this is a microscopic picture of a lot of very, very small organisms called infauna that might live in between all of the grains of sand and clay and sediments. So this graduate student wanted to understand what was happening while the community organization Paepaeʻo was removing mangrove. She wanted to follow that and see if there was also a change in the benthic and infaunal communities. And so this was one of the things that the students were involved in. They were involved in netting different organisms right outside the mangroves. They placed some of these what are called predator exclusion cages to see what was happening if you took away some of the predators that are using the mangroves as cover. They took sediment samples and they would sieve these and look through those for the infauna. So they were involved in all of these aspects of studying mangrove communities. And in the end, they actually were contributing to some data, and the next couple slides that I'm going to show you have been published by this graduate student. So these students contributed to some published research. This is just mangrove biomass. That is the sediment that mangrove created while it was in the fish pond. And as you can see, over time, it does happen that that mangrove sediment does get removed. So here's present, there's mangrove still present here, and there's a lot of sedimentary biomass here, but it does reduce the further back you go for when the mangrove was removed. But more importantly, they also showed, so here's that same map that I was showing you of time of removal of mangrove, and the infaunal densities. So this is number of organisms per area, say per square meter, are much higher in the areas that have been removed for a longer time, showing that actually once you start to remove the mangrove, the infaunal communities in those areas will start to come back, and they'll start to be able to move through the sediment. It's not as dense. And probably after this, after you get more infaunal communities, you'll probably get more of the organisms, the benthic organisms that might eat these infauna. And so restoration of that natural ecosystem, that natural food web that would happen without the mangroves there. So another thing that our students were involved in is measuring water and sediment chemistry. They measured things like phosphorus and nitrates and iron in the sediments. They were measuring the oxygen of the water. They were measuring chlorophyll in the water, and all of this to better understand what is the existing situation, what's the existing condition in the fish pond, and how will that change as it's restored by Paepaeʻo Heʻeia. So these are pictures of our interns taking water samples and sediment samples. They learned a lot of chemistry techniques. This is actually at the fish pond, set it up at the picnic benches there, and you can say this is like lab paper that has been put down over all of the picnic benches, and they are titrating seawater to get a measurement of what the pH is in that seawater. So this was done right on site. They're filtering water and taking those filters and measuring chlorophyll in there. So a lot of techniques. I think that this particular one was for oxygen. They were going to determine oxygen in the water. And all of this was important for Paepaeʻo to understand so that they knew how they were affecting the fish pond for the better, how they were improving the fish pond as they were restoring it. And then another study that they were involved in is the distribution of algae and mapping where algae occurred within the fish pond. This was a really challenging project because the fish pond, as you can see, is not very clear. This is pretty typical. It's murky and muddy, and you can't see into it. So you can't really just put something down and look to see what's on the bottom. You have to feel. So there are 3 different kinds of algae that are common to the fish pond. And what this particular intern is doing is she's put what's called a quadrat down. It's just a square of known size. And it's got these smaller squares tied off. And she's putting her hand in and measuring each kind of algae by the way it feels, because you can't see it. So they had to learn to identify algae by feel. And that's one of those right there. And they would go out and they would paddle themselves out to different areas. They have all of their equipment, GPS, quadrats, this is their depth pole, lots of things. And they were also, they were collecting samples of the sediment. Here's a plunger kind of apparatus made from a syringe top where they plunged it right into the top of the sediment, and then they would collect that very, very top layer, and that would tell us what kind of microalgae were on the surface of the fish pond. Microalgae are really important for fish ponds because the fish that are often grown in fish ponds are grazers, and they like the microalgae that grows on the bottom of the fish pond sediment. So it's important to know what is there. Okay, so that was science research. And as I mentioned, monthly, they got to work with one of our 2 cultural advisors. This is Donna Campbell here with 2 of our, this is Megzi and Cheryl, our 2 of our graduate students. And this is a postdoc, Kim, who happened to be with us for that day. But Auntie Donnie would meet with the interns and tell them about the mo'olelo that was important in the area of Heʻeia, the history of the fish pond, what were the practices, what happened, why they were situated the way they were, who used them, and the land uses in general in the Heʻeia area. Auntie Donnie is very knowledgeable about the historical land uses of Heʻeia in particular. Her family actually owns kuleana land way, way in the back up past Haʻiku Plantation, past the actual development of Haʻiku Plantation. These are the Ko'olau Mountains. This is her family piece of property, and they do some taro farming here. There's no electricity in this area. They were granted this land from way back in the Mahele, and her family was actually able to hold on to it. Every 6 months with a new set of interns, she brought them back to this place to tell them about all of the land use practices. And so it was really special for them. This is a sunrise ceremony where they were watching the sunrise, and she taught them a chant that the Hawaiians used to use to welcome the sun called E Alae. And this is a makahiki ceremony that she invited one of the groups to join her in. So not only were they getting, excuse me, the science research, they were getting the cultural context and all of that traditional knowledge that goes along with it. In addition to this, they also worked with Hi'ile to learn some different fishing practices, both traditional, just this is a bamboo pole fishing, net throwing. They learned how to husk coconuts to prepare fish in a few different ways. They learned how to net for crabs. This is a nice big crab that Lissa caught here, Simone crab, delicious. They actually ate those later. So again, local and traditional practices that go beyond not necessarily just the history, but what currently is important to folks that are using the fish pond. Okay, and then finally they were involved in service. So as I mentioned, Paepaeʻo Heʻeia is trying to restore its wall, and it's trying to remove invasive limu and algae that's growing in the pond. So every month our interns would pass buckets of rocks with other interns. They have twice a month, they have a community work day on Saturdays. So once a month we would join that, and we would pass rocks, we would haul boulders, anything that they needed us to do, we did. This is collecting invasive algae and then passing them upshore. That algae then gets distributed to local farmers in the region that use it as mulch and fertilizer. So we like to think of the internship as a very holistic experience where they were getting a lot of different kinds of opportunities and experience, not just the scientific research. And then finally, as I mentioned, every 6 months when a particular group was finishing, they would share their research with the community. They would invite whoever they wanted to come to the fish pond. We always catered it. We had lots of food. People brought other food, and they each gave in pairs. They each gave some aspect. They presented some aspect of the research, and they made their poster boards themselves and talked. And then we just had a fun, kind of hangout and talk story session. So I am a researcher, so I couldn't let you get away without a little bit of data. But this data is on the impact of the program itself. I'm actually just starting to write this up for publication, but this is some of our survey results. I just wanted to give you an idea of our participant ethnicity. So we did have, HPP means Hawaiian, Polynesian, or Pacific Islander. We did have quite a large proportion of our interns were underrepresented minorities. And it might be hard to read, but it says, has your experience in the Laulima ʻIke Pono program influenced your interest in natural science, environmental studies, or resource management, or interest in participation in environmentally or culturally focused community organizations? And we got very, very strong response that they actually, their participation in the program influenced them wanting to do more of this kind of work. And I've just given you a couple of quotes from some of the open-ended questions that we asked them. They learned that there's different ways to get involved in field work than they had realized, and sparked their interest in management and biology. So having Heʻeia Fish Pond as that place was something that then it was very special to the interns. You could tell as we ended each time, they all were very, very connected and very attached to the fish pond. And having that attachment, I think, is part of what generated a lot of the interest for them to continue going, because it was a personal connection. And then also, this is small, I apologize, but it says, I'll read it for you. It says, as a result of Laulima ʻIke Pono internship, please rate your growth or improvement in the following areas. This is understanding the connection between land and ocean. This was on a scale of 1 to 4. So as you can see, we only start at 2 here. We didn't have any responses actually that were less than 3, and 4 was the highest. So understanding the connection between land and ocean, your interest in scientific research, understanding physical and biological processes important to the fish pond, understanding traditional native Hawaiian practices, identifying key organisms in the fish pond, just working in the field in general, and conducting scientific research. So we found that the interns had felt that they had improved, or their skills had grown in all of these areas as a result. And we had very high program satisfaction as well. I like this quote because this person appreciated the integration of the science and cultural practices and was very interested in continuing that as a career, of actually integrating those two knowledge systems and practices. And so that was sort of the impacts on our interns, but we had another project associated with the program, and that was to try to reach out further into the community and provide some information to broader audiences. So how could we impact the broader community? And this is a iPhone app that we created with the help of also an intern and a little bit of funding from a private foundation. And you can download this on your iPhone. I'm trying to hopefully find some funding so that I can also make it for the other platforms. But it's just called Local IA in the App Store. And you can find out more about it here in this website. But it offers a walking tour. So if you're actually at the fish pond, you can walk, and it will prompt you at different sites and give you information about that location, tell you about the scientific research that was happening there, give you some of the cultural practices and knowledge as well. If you're not at the fish pond, so let's say you're not even in the United States, you can actually do a virtual tour, and you can push each of these buttons. It will give you information both about science and cultural practices in the fish pond. And this is an example of one of those science maps. Remember I told you that the interns were studying algal distribution? Well, this is actually a map of the different kinds of algae in the fish pond. And this is wet season, there's one for dry season. So that is now available, and I think Paepaeʻo tries to get as many folks to download it as they can as well. It's free, it doesn't cost anything, and it also helps them with their own tours. They can say, hey, if you want more information about this, you can go to this app and you can find out more. So with that, I might have gone kind of quickly, but with that, I'll just say thank you, and if you've had any question, I would be happy to answer them.
Any questions?
Oh, yes.
Yeah, you have to monitor now that as the mangrove gets removed, you have to monitor the sediment, any of that sediment going back and then the cutting bay now to the opening.
They do. So now that they are closing the wall, their Department of Health permit requires them to monitor the sediment that might be going out as a
discharge.
As a discharge, but not actually for the mangrove removal, only for the closing of the hole in the wall. Because actually when you take the mangrove out, you're reducing the chance of sediment going into the pond, because you're creating tighter connections between all of the rocks in the wall. So you don't, the wall is no longer falling apart. The wall is actually better at keeping the sediment in. And they do not have a plan right now to try to push the sediment out. Obviously, we don't want that to happen on our reefs. So once they get the hole in the wall closed, the plan is to just see how the pond then functions, and see if they can just use it as is. It's definitely shallower than it was historically, but as I said, once some of the natural communities start to come back, they might get a little bit of bioturbation in that, and they might find that the sediments oxygenate and they can utilize it as is without having to do anything with the existing sediments. Yeah, but I'll take your question first and then.
it sounded to me when you first started, they were trying to return the bay to what the Hawaiians had it originally. But as you go on with the program, I see you're leaving all this sediment. To me, it's
Right, so
not quite the same thing.
they're trying to, and they are not restoring the bay as, not the whole bay, just the fish pond,
Yeah.
which is 88 acres walled in part of Kaneohe Bay. So what they're trying to do is make the fish pond functional again to raise fish for the community. Right now they have an issue that there's a whole bunch of sediment in the fish pond.
Yes.
They don't want to take that sediment out of the fish pond because then it actually would be impacting the reefs of the bay. That's why they want to keep it in.
On land.
Well, that's possible that they might actually be able to do that, but they have to, again, get a permit for that. So right now they have a permit to close the wall, and then they can see if the fish pond functions well enough for them to just leave the sediment there. Because if it's in the fish pond, it's not going to go out onto the reefs. And if they need to then remove the sediment, I suppose then we'll look at what our next steps are for trying to remove the sediment and taking it somewhere else.
Where did the sediment come originally? Flowing off the ground?
Yes, from,
What happened to the original Hawaiians? Did they have sediment?
well, their agricultural practices were slightly different because they terraced things, and they actually held water in their lo'i, their taro lo'i, held water for a long enough time that the sediment settled out. And then they probably dug out their taro ponds and took the sediment other places. Further, so a little later, agricultural practices did not use that kind of terracing. It was watered in a different way. It was, essentially there was a lot of runoff. Pineapple requires a lot of water, and that was probably contributing a lot to that sedimentation. Then there was also sugarcane and rice as well. Rice probably didn't contribute as much, but because I think what happened is that they turned a lot of the taro lo'i into rice paddies. But then with sugarcane and pineapple was really what started the runoff. Yeah. Yeah, so I'll take one here.
In reading about some of the fish ponds,
Mm-hmm.
they talk about the fresh water coming in from streams.
Mhm.
The stream looks like it's outside of the
yeah.
area. Was that a change in the geography?
No,
Geology?
no, I just didn't describe it well enough, and I'll show you, actually. They do have,
You mentioned one of them that's off to the side.
yeah, so here's the stream. There's actually a couple of inflows into the stream, but the main part is here. What I didn't mention is that, so the fish pond has sluice gates that let fish in and out at different times. It has gates here that allow fresh water in as well. So right along here, it's almost impossible to see because this is really interesting. This is the original wall here, which goes right up against the stream. All of this is mangrove sediment that has built. So if you just let the mangrove grow, it would just continue to grow into the center of the fish pond and completely, yeah, cover it up. Yeah, yes.
Who gets to use the fish? Only Native Hawaiians, or anybody who lives in the community, or anybody who lives in the state of Hawaii?
Yeah, so right now what they've been doing, it's a good question, and their approach, they can't really grow fish right now, but they,
Yeah.
right, but they have used sometimes some pens here. They've tried to grow some fish using enclosed pens. And what they do then is that it is because the Native Hawaiian system was a sort of regionally managed system, they feel like that resource is first to be shared with their immediate community around here. And what they do is those folks that come and help volunteer at the fish pond, they announce that we'll have fish available, and if you want to come get some fish, then you can. They haven't had very much though at all. Once they start to really produce fish at a large scale, that's another question. They probably need to actually develop a business plan for that. Yes.
So presumably the other thing that changed with agricultural practices was use of pesticides and
Mhm.
fertilizers. Presumably this pond sediment has a lot of heavy metals in it, residuals from pesticide use. How are you testing the fish to see that they aren't actually passing on heavy metals to?
Right, so.
That when you grow fish now in a pond. that's
Right.
bad.
Yeah, so actually right now, they do have some test fish in there, and that is part of what the Department of Health is requiring them to do. Yeah. These fish don't eat, they're not, some fish actually will eat the sediment and then filter it out and just take the organic matter. These graze kind of right at the surface. They only take that algal layer there. But it's still an important question as to whether the fish have
Just
metals in
because
them.
some water samples on the water, the amount of mercury that's in every stream right now. Presumably there's mercury in this pond too, which doesn't really go anywhere.
Well, there's mercury actually in the saltwater fish that we eat also.
No, exactly.
Yeah.
So.
Yes. Yeah, no, it's, right now they have to test the fish as they're growing them up. And I think that will probably continue, is that they'll have to show that the fish don't have heavy metals. That's a state thing, yeah. Yes.
Once you get your funding, what's your timeline on closing how long do you think it would take to close
They've already started. They're going a little bit by little bit. Their goal was $100,000, and they are more than halfway there, raising that amount. They have a fundraising campaign right now, if you're interested, called Panikapuka, and if you go to their website, you'll see it right on there. So they've started already. They, I think, would like to be done, if they can, by the end of the year. But it's not clear whether they'll be able to do that or not. There's a really deep part right in the middle of this that is going to be difficult for them to, they have to just slowly build up rocks. And what they have right now is, I don't know if you can see it. If we turn off the lights again, maybe you can see this. Someone who tried in the 1980s to use the fish pond kind of built this temporary wall here, and those are made of concrete test cylinders from all of the concrete that was being poured on the H3 at the time. And so these are all test cylinders that were just going to go into landfill. So she brought them here and built them up and kind of built the wall. That's also now crumbling. But what will happen is those will now form the very bottom of this, and then they'll start to build up. So I think, yeah, it just depends on how quickly they can move while still staying within their permit parameters and buying materials, essentially. But they had planned for about a year. They did start earlier this year. Yeah.
Is there any way they could come in and drive piling and then make your wall much stronger?
Yes, but they don't want to. For the same reason that they actually, none of this has been cleared by any mechanical equipment other than some chainsaws sometimes, but it's all done by hand. They could actually have just, created some, I guess, fill and then drove bulldozers out here or other machinery, but they didn't want to do that either. They actually wanted to do it by hand, and that's why they have all of these community work days. Sometimes 100 people at a time out here working in the fish pond. Yeah.
Just as a totally, not irrelevant, but they've had one fishing day where they want us to take predators.
Yeah.
Are they going to do another?
Yeah, actually, they usually do one a month during the summer months.
Okay.
Yeah, so there's usually 3, sometimes 4. So just look on their calendar. Yeah, the La Holo Holo are opportunities for people to come in and fish. They don't want the predators in there, obviously, and you can take the predators. You have to, any of the grazing fish, though, you have to leave in the fish pond.
I could do reticence.
Oh, yeah. It's a lot of fun. They get a lot of, yeah, so they will. He'eia said that they will have that again this summer, and there's either 3 or 4, I can't remember. Yeah. Yes?
So there are no makaha along the wall?
No, there are.
Along the stream?
There are 3 makaha along the stream, and there are 3 makaha. Here's one.
Okay.
This is another one right over here that haven't been restored yet, and then one right over here. There are 3 makaha actually in the saltwater area also. Yeah.
Any other questions? All right. Well,
All
thank you
right.
so much.
Thank you, guys.